Hi, in this video I want to give a deeper dive into Docker. My previous video was a 10,000 foot overview of what you can do in Docker to sample and explain it and see it visually. Now I want to explain what the hell it's all about. What are we trying to solve? And for that, unfortunately there is a bit of a history lesson, but it's a cool history lesson in that way back in the day, you need to get system administrators to set up a physical server. And I mean a physical server. He would go in, and that space there would become your new slot for your new app. He would, or she would, get the operating system, install it, patch it, configure it, get it set up on the network, get routing set up, and then it was time to get your app installed, right? It was time to get your app on there and running. So you would generally get something like FTP, and you would connect and you would ship up all your files, and you would complain that it didn't have a particular library that you needed for Apache, or it was on the wrong version of .NET and all that stuff. And eventually you and the system administrator got together, you pressed F5 on your browser and your app appeared, and you kind of went your own separate ways. And a couple of weeks later you realized that certain page wasn't working because of a certain problem with the server, and you phone him up again. In the meantime, this guy is going through each one of these servers one by one, speaking to the customer to say, do you know what? You really should be shipping your operating system to the latest version. It's a security problem. There's problems with it. We need to migrate. And they would sell you really another server. And they would say, right, okay, see this slot here? That's now yours. I'll buy you a new server. We'll get it up and running. It's going to cost you, say, 700 quid a month. But it's the latest operating system, fully patched. And what I'll do is I'll migrate all of the code and systems off your current server and move it onto the new one. So, as a customer, you'd say, right, great, okay, at least I'm secure, at least I'm safe, I'm doing quite well. It's a nice shopping app, and should it get hacked, we'd be in a bit of trouble. So, we migrate everything across onto that new server. Now, imagine that now times 20. Say you got 20 servers. That's a full-time job. That's a system administrator for you, constantly moving and migrating and shipping and getting that new operating system, getting the system patched, getting it secure, and monitoring it. Now, times that by 20,000 or 200,000 for the servers you can see in some of these rooms, you're in trouble. You actually can't do it. You just simply don't have enough days or manpower to warrant replacing all of these things. So the the problem that we had was we couldn't keep this stuff up to date, and we couldn't patch it. So the solution that came about was virtual machines and virtualization. What happened was we would configure a whole host of these servers to act as one, and we would allow customers to FTP in, but they would only get a sliver of that resources, only a sliver of that CPU and disk space. And when they went into their drive on the FTP area, they could only see their files, and they couldn't navigate up. If they went forward slash, it was literally the top of the directory, and it was just their stuff. And it was virtualized. And it meant that that rack of servers there could be configured as one, and maybe there would be a couple of thousand customers all sharing that. So now there's instant value. Instead of one server, one customer, one operating system, and having to do this hop swapping, there was a whole bank of racks, like U1, U2 racks, that were literally working together as one beefy server, which would then allow the management of it and allow customers, thousands of customers, to be logged in. And software got better. Things like Apache got better, and other software to virtualize these environments so that multiple customers could have the software running on this hardware simultaneously and not really get in each other's way. If one client crashed, it didn't necessarily crash the other person's client's computer or server. So it was a very cost-effective way of delivering. Now, you're not going to get this for free. This isn't magic. Configuring these servers and getting them all to work as one wasn't out of the box. And you had to go and get some specialized software and install it on each machine to allow them to cluster together to act as one. And that was timely, that was costly. And eventually there was software that was developed that run over the top of these things. Which were management infrastructure software that allowed you to manage each server independently. And you could quite easily unhook one server, patch it with the latest operating system, and then reconnect it to the cluster, and it was up and running again. So its base operating system was always being updated. And that meant that as long as you had a full rack, well, as long as all these customers could run off maybe 70%, 80% of the push CPU and memory space for this whole cluster, then one of these things could be taken out, just detached from the cluster, the operating system reinstalled, refreshed, repatched, and reintroduced to the cluster, and there was software that managed that. Now, a customer still needed a computer. Let's say we got to Windows. They still needed to be able to log on to a Windows server. They asked you for a server, and what a customer thought they were getting was a particular rack. Like one of these belonged to them and was theirs and was plugged in. And in actual reality, what was happening was they were getting a sliver of the CPU performance for this whole cluster here. And they would log in and they would log in to a VM, a virtual machine. Now, a virtual machine is just an operating system running in software, running in memory that's utilizing another operating system as its host. So, say for instance, you've got Windows installed, sorry, and you want to install Linux. Well, you can install some virtualization software, and that software allows you to install another operating system on your existing platform during runtime. And you can just click a button and hop from your host operating system into the virtual operating system. And you could have a version of Linux, another version of Windows running on your system. Now that was great because the host operating system was the big cluster, some low-level management software that runs that. But then running over the top of that could be something like VMware, which allowed you to then make 50 or 100 VMs out of this. So cost-wise, you had 20 servers now that you could now sell 100 times, well, 4 or 5 times over. So, 10 maybe might give you 50 or even 60 VMs now that you can sell to the public. Well, that was massively cost benefit because beforehand, one server, one thing, one manager, one system administrator to keep it up and running, and it was a pain actually. It was awful. Where now you could really get bang for your buck. A server host could set up this cluster and sell it 3 or 4 times over by just having virtual machines. But if you remember right at the beginning of my rambling rants, and I love this stuff, so bear with me, we had to plug in a server and configure it, and then they wanted the operating system updated, so we got another server, installed the latest operating system, and lifted and shifted the code out and over. If anyone was going from like Java 3 to Java 6, you had no chance. It just wasn't going to work. People had to reinstall or recompile and update libraries, and it was catastrophic. The systems just didn't work. There was loads of effort and time put in. The problem is that that's still true with virtual machines. Just because we've made it software driven and not physical hardware doesn't mean we've actually really solved the problem. All we've done is allowed system administrators to sell 40 VMs from 20 servers or 60 VMs from 20 servers. We haven't really solved the problem. And virtual machines are an operating system, fully fledged operating systems. They need patching, they need maintenance, they need support, they need updating. If you want to go from one version to another version, it's a full clunky thing. But also, these things take time to start up. Back in the day, an operating system could take 3 or 4 minutes to boot up. things are getting a little bit better, but even SQL Server 2019 can take between 20 and 40 seconds to fully boot up and be operational. So if one of these machines goes down, your site could be off for just under a minute. If you've got multiple VMs to run your infrastructure and run your sites and your systems, you could be offline for a couple of hours based on these things firing up. And they are very, very hard and difficult to manage because we didn't actually solve the problem. We just solved the hardware problem. We didn't solve the software problem. Now, way back when we were talking about virtualization and allowing a customer to log in to say their FTP area and only see their files, there were Linux initiatives that were going on that allowed customers to SSH into a shell, a remote shell, and be able to rummage around their system and rummage around their what they thought was their own computer, but it was virtual again. They went to /root /bin. It was their version. If they decided to delete their bin directory, uh, don't do that. But if they decided to delete their bin directory, then they were only messing with their own stuff. The whole system carried on running, and it didn't affect any other customers. And this chair route and this locking people into their own virtual operating system got better and better. And they learnt how to do this. And even CPUs started offering support for virtualization on the CPU stack. I mean, so this was not a software, right? This was stuff that was supported by the actual hardware, by the CPU. You could physically allocate memory that could not be accessed by another system, even with all the hacking in the world. Now, I'm not saying that's technically impossible. I'm just saying up until now, it's been very, very, very difficult to achieve. Now, this spawned what was just genius, an absolute genius idea in I don't need an operating system. Why am I re-implementing a brand new operating system? Now, I'm not going to go into what an operating system is because you should know this. If not, there's better videos on this. But generally, the operating system has a low level kernel, and that's the thing that does the work. It speaks to the hardware. It allows when you press a key on your keyboard for all of that data to go through the board and actually then appear on your screen, controlling hardware, controlling memory, understanding the binary instructions and working out where and how to process them is all the power of the kernel operating with its core hardware and understanding what that is. It's an incredibly complex piece of software, probably one of the most complex ever built. And we are re-implementing that with VMs over and over and over again. But because we got very good at virtualization, and virtualization was even supported in the processors, then there became this idea of, well, we will just use the underlying operating system, stick some software over the top of it, and make it pretend using this virtualization ideas that we have got multiple servers, where in fact we've got a low level server. It's not really a server, it's not a VM, it's a container because it contains just the stuff to make it look and appear like it's an operating system in its own right. When a customer logs on to app A, they will see an operating system. They will see a clock, they will see hard drive space, they will see CPU and memory and performance issues like you would on any machine. And they can rummage around it and they can format it, they can delete it, they can mess with it, they can patch it. But at the end of the day, they're just patching their containerized instance. And because there is no operating system within the container, it can boot up in milliseconds because the operating system is already running. So we utilized the existing ecosystem of VMs, virtualization, Hyper-V, VMware to then run a a host operating system, which then has a Docker operating system. Now, the Docker operating system does the magic of allowing all your containers to run and use that one Docker image. So you have your infrastructure, your hardware, all this gubbins. You have a virtual machine running, which is a fully fledged massive operating system, very complex. And that operating system is running Docker. And that it gives an ecosystem that allows you to have all of these containers running on top of Docker.